Welcome back, everybody. This is the chapter 6 of 15 of lesson 2 of CryptoZombies, and yeah, I would say it went better last time, in the last episode. My name is Lou, and we're gonna carry on this Ethereum journey. Let's start the chapter. Put it to the test. Now that we've set up a multi-file structure, we need to use import to read the contents of the other file. Import zombiefactory.sol into our new file. This seems pretty simple. Watch me mess it up. /zombiefactory. Looking for typos, zombiefactory.sol, and add in the infamous semicolon. Check answer. Triumphed. Let's do this. We want to have a whole video without pressing the show me the answer button. Let's see how that goes. Put it to the test. It's time to give our zombies the ability to feed and multiply. When a zombie feeds on some other life form, its DNA will combine with the other life form's DNA to create a new zombie. Create a function called feed and multiply. It will take two parameters, underscore zombie ID and underscore target DNA, also uint. This function should be public. Don't want to let someone else feed on our zombie, so first let's make sure we own this zombie and add a require statement to verify that message.sender is equal to the zombie's owner, similar to how we did this in create random zombie. Create a function called feed and multiply. Got this, so this is without looking. Function feed and multiply with parameters. See, this is where, okay, yep, just need to bring you back a bit. So then it's the parameters underscore zombie ID. Oh, uint first. Uint zombie ID. Remove one of these brackets and underscore uint target DNA spelled correctly, which is also no, that's not underscore, this is underscore. This function should be public, so public, and then the actual function body. Oh, it feels like I'm properly doing this. This was promising, even though I'm just calling a function. Feed function, okay, yep. And add a require, so then we're going to add require. It says add a require statement to verify that message sender is equal to message zombie owner. So let's take this as an example. Wait, no, that's wrong. Require oh, okay. I've It's actually this one, isn't it? So I need the zombie2 owner. No. Require zombie2 owner ID equal message sender. We don't want to let somebody so I require let's think about this logically, okay. So I require message.sender to equal zombie owner. I don't know. We don't know. We don't want to let someone else feed our zombie, so let's make sure that we own the zombie. Add require so do I need to put this in here? With zombie2 owner. Okay, I'm just going to go back a few sessions because I think the answer is here. So check answer, show me the answer, because I've already done this, so I can't. It's okay to go through this bit. Is that all we did? Require okay. Let's go back to chapter 7. Oh no, it's deleted everything. Let's try that again then. Function feed and multiply uint underscore zombie ID, then uint underscore DNA, and then add public, and then the function body, and then require sender equals that, and if I go into here, equals message sender. Okay, that is a gamble. So basically that's saying I require the message sender of the zombie owner equals message sender. I don't think that's... Logically, that's wrong. I know it's wrong. Maybe, actually. Okay, what I'm thinking now is using this function here, this variable here, message sender. Oh, I don't know. I have no idea, so I'm just going to put just question marks on that one. There should be 4 lines of code. What? Waited 3 of them already. Okay. For the final line of code, when we're going to need to get the zombie in A, so the next thing our function should be is declare a local zombie named myZombie, which will be storage pointer, set this variable to be equal to index zombie ID in our zombie array. So we're going to need to get the zombie's DNA. So the thing our function should do next is declare a local zombie named myZombie. This is how you declare a variable, right? Wait, it's not going to be uint, is it? It's going to be storage. My declare a zombie. Storage myZombie equals zombie ID. Oh, equals zombies. This has not gone well. So zombie requires storage pointer, set this variable to be equal to index zombie ID in our zombies array. Okay, so I think that's right because this is a similar line to this one. Sandwich storage my sandwich equals sandwiches index. So I think that's similar to what it's asking for there. So yes, things are going to be very wrong. Yeah, we expected that. Contract zombie feeding. Okay, first off, all of this is under... Oh wait, no. That's... How's that wrong? That was given to me, I think. Okay, it's already... Target. Yeah, that was a typo. Try again. Okay, so the thing I'm missing is the require, but we all agreed that that was going to go wrong. and I just don't quite understand the so what am I doing wrong here? So okay, fine, I'll play by your rules. Oh wait, no, it says import. Yep. So just getting rid of all these red markers. So require message sender. Again, okay, I've got issues with the require function. Message sender equals zombie to and then it's underscore zombie ID. Okay, let's talk this through and also add a bracket because that's what they also wrote there. Let's get this understood. Require message.sender equals zombie2owner, zombie ID. So what it's saying here is you need the message sender to equal the zombie owner, or that they own. Okay, just essentially say that message sender owns the zombie ID. Yeah, that makes sense. Let's read this one again. We don't want to let someone else feed on our zombies, so first let's make our own make sure we own the zombie, and require a statement to verify the message sender is equal to the zombie's owner. Require message sender equals to zombie owner, zombie ID. Oh, because the zombie ID is going to be the uint, and due to the mapping, it's going to get from the uint to the address, and the address will be the message sender, because the message sender will be the zombie owner. I think that's correct. Okay, let's try again. Look, well done, we've done it. And then move on to the next one. First, we need to make sure that the target isn't longer than 16 digits. To do this, we can set target DNA to equal to target DNA times modulus, only to only take the last 16 digits. Okay, so start here. So the target DNA equals to target DNA to DNA modulus which will be all good. It has 16 digits, yes. So finish that line. Next, our function should declare a uint named new DNA. New DNA, and set it equal to the average of my zombie's DNA and target DNA. So this is essentially this one. So copy that, put that down. But we're using, so rather than zombie DNA, we're looking for target DNA there we go. So I'm using this note, this could help us. So my zombie.dna plus underscore target DNA. Target DNA, and we're good. That's divided by 2, and the equals new DNA. Once we have the new DNA, let's call create zombie. You can look at the zombie factory sol tab if you've got which parameters this function needs to call. Note that it requires a name, so let's set our new zombie's name to no name for now. We can write a function to change zombie's name later. Note, for you Solidity whizzers, you may notice a problem with our code here. Don't worry, we'll fix this in the next chapter. I won't be finding this problem anytime soon. So I need to create random zombie. And the name. So this is going to be no name. And then this is going to be new DNA. Booyah. Okay, let's see how this goes. Thank you. I feel validated from my previous failure. Okay, on that note, I may keep that as a success and move on. And by move on, I mean stop and see how we go next time. Thank you for listening, watching, and as always, if you've got any tips, advice, just anything to help me on this Ethereum journey, please let me know. And yeah, subscribe if you fancy it too. I've been Lou, and thank you once again.